Bruh. Hello, gamers. And welcome to a new stream about writing GNOME documentation and application code. Hi, Dukies. Oh, how's the Monday morning? Well, Monday morning, afternoon, evening going? Oh. Oh. I just found out that there are a couple of bugs in glib, yay! And one of them breaks the build on macOS, which is fun. Luckily, it's all bleeding edge stuff, so we don't have to actually care that much. But yeah, hopefully it will be fixed soon-ish. Fingers crossed. Sadly, it's one of the issues that we currently have is that not every... how do I say this? We have a CI pipeline that runs on every platform that we offer support for, which is usually a couple of distributions on Linux, mostly Fedora and Debian. Debian stable. Then we also, for glib, we also have the x62 and Visual C++, Visual C pipeline on Windows. And then we have macOS, and then we also have Android. But sadly, the macOS build machine, well, the macOS CI job is running on a native build, and the native build is kind of flaky. We'd like to move it to a VM, but it's complicated and requires somebody that knows how macOS works to deal with that. So ideally we want to move it to a VM so it's more self-contained and it's less flaky. But yeah, one of the results of that flakiness is that we don't run it automatically, we run it manually. Well, we run it automatically only on the main branch. So we identify at the very least breakage that occurs once stuff has landed. But the job on the merge request pipelines doesn't run, which means that we don't always notice when stuff breaks on macOS. And guess what? Something broke on macOS. Running CI pipelines is kind of complicated on stuff that you don't have complete access to. And by complete access, I don't mean just having the hardware or network access. You also need knowledge, at the very least, which is kind of complicated when everyone contributing on a free software project usually is running Linux, and sometimes they're running Windows. Very few people run Mac OS. We generally notice that something broke after, if not on the CI pipeline, we notice that something broke because projects like Homebrew or MacPorts file issues about it. But those projects have the tendency to ship distribution patches, which hide a lot of the problems. And of course, they use releases. They don't use the tip of the Git development branch. So that stuff gets noticed way down the line, if it gets noticed at all. So the usual up and downs of developing free software projects that are portable to different platforms. What are you gonna do? Okay. Let me double check where we at now. Right. Of course, it's Monday, so I expect stuff to break on Monday. It's just the way it works. It either breaks on Monday or it breaks on Friday. We've gotten better at not landing stuff on Friday. Except we do releases on Fridays and Saturdays these days. And that usually means breakage landing on the weekends. And that breakage gets fixed usually on Monday, which means more breakage. Imagine if computers actually worked. Anyway. Today I actually wanted to do something a little bit different. Well, different up to a point. One of the things that I've tried to do with the getting started documentation for the GNOME developer documentation, the getting started tutorial, sorry, for the GNOME developer documentation, was to try and have it in different programming languages. We have a baseline of C because that's what we generally use in our libraries. So it needs to be, it's our base language, even though I strongly recommend not starting out writing GNOME applications in C. I know that there are people that really enjoy C and recommend using C even for, at the very least, for their purposes. But for newcomers to the platform, I would strongly advise not to use C. This means that our documentation should come in a variety of flavors, of course, for a bunch of programming languages that we kind of support. I struggle to define support in the GNOME developer platform because there is no actual support anywhere. People continuously ask if there is an official Python or official JavaScript or official Rust or an official language for GNOME, and there is really no official anything. If you ignore the fact that our libraries must expose a C ABI, there is literally no official anything in the GNOME developer platform. So there is no official language. There are a bunch of languages that have a certain degree of support and certain degree of, if not market share, at the very least mind share. So you will find more people using that language and providing like help for that language, for writing applications in that language. Oh, since you start with Python, is that what you recommend for newcomers? I recommend a variety of languages for newcomers. I recommend Python, I recommend JavaScript, and I recommend Bala and Rust. So just like GNOME, I don't have a specific recommendation. It always depends on what you're more comfortable with. A bunch of people are already comfortable with different languages like Python and JavaScript, so they should probably pick those up for writing GNOME applications. If you are a complete newcomer and you're also starting to learn how to write applications, picking a language is probably less of a problem. You can pick whatever language at that point. If you have zero experience with programming, that's it. So Python is a good newcomer language. It's a good newcomer friendly language because it eases you into various patterns of programming. But just as I say, just as easily as Python is a good newcomer friendly language, I would say that JavaScript is another newcomer friendly language. There are lots of venues in which you get help about JavaScript. The main difficulty about language bindings is that you will find help about Python if you use Python native modules. So it's easier to find, if you're using Python, it's going to be easier to find help in Python forums about using, I don't know, outside of a standard library, probably like Beautiful Soup or any other Python, or NumPy or any other Python like native module that then you will find for GNOME related stuff. So you will have to go on the GNOME specific forums in order to ask about the GNOME specific modules. At which point you will find people to help you and documentation and whatever else. So as for JavaScript, for instance, you will probably find a lot of help if you're using, I don't know, Node, NPM, or any other like repository of JavaScript first modules. But those are for writing Node applications, not for writing GNOME application. So it's hard to recommend any single language if you're starting out, because every single language has its own venues for asking for help, has its own recommended best practices and their recommended modules. So it's always hard. And since GNOME cannot play favorites there. We cannot come out and say, oh, you should always use JavaScript, or you should always use Python, you should always use Rust. Because people get territorial with their stuff. So let me give you an example. About 10 years ago, the documentation team met up and basically just started brainstorming on the idea that we should probably have our documentation for newcomers favor a specific language. Not because that language should be the official part of GNOME, should be the official language for developing with GNOME, but because our resources were stretched pretty thin 10 years ago already in terms of documentation. So we find a bunch of people that are currently using a specific language, and they sit down, bang out a bunch of documentation that is useful for newcomers, and we present it. And then for other languages, people will pick it up and do the rest, right? Which is a sensible position. it's a sensible position because you have a set of resources and you make do with what you have. You cannot will volunteers into existence if you do that. If you don't have a specific constraint, right? And since at the time it was 2012, 2011, 2012, there were a bunch of people that were using JavaScript inside GNOME because the JavaScript bindings were pretty on the bleeding edge and well maintained because of GNOME Shell. Then basically the choice came to be saying, okay, we should prioritize JavaScript for our documentation and our tutorials and basically just push for it. Because we have more people writing new code in JavaScript than we have people writing code in Python or C++ or Rust didn't exist at the time, so we didn't have Rust. Vala was in a lull, so kind of... also, Vala was very specific to the GNOME community, so it didn't have any additional documentation outside of what the GNOME community could provide. Well, the Vala community could provide at that point. So JavaScript was probably the most sensible option, and it was announced. And when that was announced, all hell broke loose. People were saying JavaScript is the only language for GNOME. People were going to say GNOME is abandoning every other language binding. Python, the Python community inside GNOME and outside GNOME was like, what the fuck? Are you... you're shutting us out? What the hell? And then of course the floodgates were open, saying, oh, JavaScript is a shit language and JavaScript doesn't work and JavaScript is terrible because of the web. And everyone was like, we didn't say any of that. We are talking about prioritizing documentation. What the fuck? And that basically taught us two things. One, never announce anything during an Hackfest. That is a shit idea and nobody should ever do that ever again. And the other one is that GNOME cannot commit itself to prioritizing a single language. So the only reason why currently we have examples in C and Python is because I write both C and Python. I'm not a Python developer. So people that know Python are very much welcome to come and fix my Python code, which is most of the time atrocious. But every time I do this, every time I write documentation, every time I do a stream and stuff like that, I literally prefix everything with I'm writing C and Python because those are the two languages that I know fairly consistently. So I'm confident in writing Python and C code for our examples, but people that know other languages should come by and open merge requests for adding examples in other languages. And that happened. We already have Vala and JavaScript examples that have been merged upstream, so it's great. I made sure that the infrastructure is there so that people can contribute their own examples in their own preferred language. The GTK website has examples in multiple languages right on the landing page. So you have you go to gtk.org and you find examples in C, Vala, Python, Rust, Perl, C++. So it's pretty clear that we are not trying to slight anyone. Which has its own downsides, of course. The main downside is that if you do not constrain yourself, you end up in a very bad situation with documentation and promotional material that is too unfocused. and you open up yourself to the problem that people arrive at your door and will ask, what should I use for writing GTK and GNOME applications? So you invite the question. If we said we mainly support, like, I don't know, Python, then people will come into the community and say, okay, if I don't use C, I have to use Python, right? So it would be a lot easier for us. But again, you cannot really completely shun an entire class of contributors and potential contributors just because you want to constrain yourself and avoid answering questions. The other issue that you open up yourself about is that you need those language bindings to be always up to date and always reliable and have good tooling so that people can actively use them. If you only support a couple of languages, like say you support C and you support JavaScript, for instance, then you better have really good tooling for C and JavaScript. If you say I'm going to support C, JavaScript, Python, and Rust, then you need tooling for like 4 different languages, and that is not easy to make, not an easy task. If you say we support every language in the world, then suddenly you need to have every language in the world to have good tooling, which is just not the case. I mean, Vala is what, 15 years old, and does it have good debugging tools? Not really. So we are still kind of, if you don't limit yourself, if you don't give yourself constraints, you kind of make everything more complicated for yourself. And once you make stuff complicated for yourself, who is ostensibly the provider of this platform, then you make it more complicated for the people that are consuming the platform. And at the end of the day, you will find out that the only language that we truly and like wholeheartedly support is C, and C sucks. It's a bad language. It's a bad language for a lot of reasons. It has a variety of problems. It doesn't have great tools unless you already know C and you already know the limits that it has. So there are no good answers there. There are no good. It's not something that we can fix by ourselves. Still, the only thing we can do is try and document our platform as much as we can and provide as many tools as we can. And maybe the next thing that people will contribute to or write is going to be a proper debugger for Vala, for instance, or a proper tool for Python development. Who knows? Stranger things have happened. I mean, 10 years ago, I would have said, oh, GNOME doesn't have an IDE, but you can cobble together stuff with Vim or Emacs or like whatever. And now we do have an IDE. We do have GNOME Builder, and it's great. And it needed somebody to sit down and actually do this. And the only way that happened is because people that have an interest in the platform will start contributing to the platform. If you don't have people with a vested interest in making the platform succeed, then you won't have anything there. Ooh, there's a lot of questions, Yukis. So let's start. Recommend using Realm to start. Realm is an interesting thing. I would recommend using Realm 4, not Realm, because Realm is GTK 3 and Realm 4 is for GTK 4. So I would recommend always to start with GTK 4 based stuff. Realm 4 is an interesting experiment. It seems to be well supported for now, but you never know what will happen. It needs more people contributing to it, more people picking up and more people contributing to it in order to make it a viable solution. But it's an interesting experiment. I don't know how it scales up, for instance. I don't know what a complex application written with Realm would look like, for instance. So I cannot say. Blueprint is another interesting solution in the problem space of UI definition files. Again, it's very new, so I don't know how it will look like. It seems it's getting adoption. I don't know. Or not use any of that and just go into the low levels, like barebone. Okay. I'm entirely confident in saying people should use as much of automation as possible. So back in the GTK 1 days, talking about 20 years ago, 20 plus years ago, we didn't really have UI definition files, but we did have Glade. What Glade did at the time was let you design the UI and then it would generate code for you out of that. It would also save the internal state as some XML file that was custom made and stuff. But the end goal was you design your UI with Glade, you press a button, and it would generate C files for you, like C and header file, and would generate the main entry point, and it would generate the code that dealt with the callbacks, so all the entry points for the callbacks, and then it would generate the UI using, like, generating C code for the UI. And you can actually see older applications, like older GTK2 applications, that basically match the fact that basically were generated with that approach. So people would keep those files and then add more to it. It was a terrible idea. It was a terrible idea. It didn't work out at all because it had a very specific model in place. You would build your UI out of specific widgets, and you have those widgets operating on everything, which is, I mean, we've seen previous streams that it's not great. It's not a great plan. The best practice is to have models and views and decouple as much as possible your business logic, the application's business logic, from the actual presentation. So we moved away from that particular model, and Glade became this: you have the XML, you generate the XML, and then some other component will load the XML and generate the UI for you, right? But that basically introduces a level of separation from the code you're writing and the end result that you're displaying to the users, right? That particular serialization model was adapted, it grew, and was included inside GTK and can generate any GObject whatsoever. Again, more and more. And now we also have, instead of having a build system, for instance, that requires running a bunch of scripts and requires learning a bunch of escaping rules that are as auto tools, and we have Mason, which is a lot more indirect. You have a domain specific language, and it does very specific things, and it can be introspected, so you can build tooling around it. I mean, older environments like Anjuta literally generated the skeleton for the AutoTools like project for you, and then had an internal parser that would decode part of the build system for you and basically allow you to tweak a little bit. But of course, AutoTools is a complete Turing complete language because it's shell script essentially with a bunch of macros, but it's that. So it cannot really be parsed unless you have a shell code parser. And now instead we have Mason, which is a lot more tractable. You can not only parse it, you can also introspect it. Every time you run it, it generates a bunch of meta information that you have at your disposal in your tools. So GNOME Builder can effectively modify a bunch of stuff for you and learn about build targets and what kind of unit tests there are available and everything else. So it's a lot clearer that way. So now we have Builder, which generates for you a ton of the project skeleton and a ton of the project base requirements, and then you can add to it. So it generates C code for you, but also generates the XML for you for the UI definitions, and it generates a bunch of other ancillary files that are more important than that. So I guess my point is there are levels that compose the concept of low level. And yes, you can go straight down to writing like the barest bone application that you can and learn how it's put together. But is it strictly necessary? No, most of the time. I mean, it's useful if you want to learn how stuff is put together, but it's really relevant? I don't think so. I mean, I know how most of this stuff is put together, but do I care? Is it relevant? If I'm trying to write an application, is it relevant that I know how the type system works in the sense of how it's implemented? No. Is it relevant that I know how, I don't know, how the entire how the GTK builder parser takes the XML and turns it into GObjects? No, not really. It's an abstraction level that I'm comfortable at. I don't need to go any deeper unless I'm literally debugging GTK. If I'm debugging GTK, of course I need to know this, but if an application developer is debugging GTK, it means that something has gone horribly, horribly wrong. At which point, what does it matter, really? So my recommendation is you should start at the level you're more comfortable at. So if you want to start with Realm because you are curious about design an application that is completely decouples the model from the presentation, then go for it. Definitely. I don't see why not. It doesn't buy you anything to learn the lowest levels of the platform at that point. If you succeed in making that application, if you succeed in doing what you were setting yourself out to do, then you still have time to go deeper and learn how Realm is put together. And then after Realm, you know how Realm is put together, you can learn how GTK Rust bindings are put together, and so on and so forth. That usually helps a lot more than starting with the lowest level possible and then building up. It helps because you have two options. The first one is, I want to learn how GTK works. At which point, if you want to learn how GTK works, you start by looking at GTK's code. If your goal is to write a GNOME application because you want to do something, like you want to learn how to write an application, you want to contribute to GNOME, you want to scratch your own itch, you have an idea for an application, then learning how GTK works internally, it's not going to be useful for you. It's not the point. The point is making a GNOME application. And if you start out, if you want to write a GNOME application and you do it and you start by learning how GTK is put together, the curve is going to be daunting, to say the least. And it will be so much easier for you to drop out and stop. Whereas if you start from a higher layer, like I start by running builder, generating everything, and then I modify a bunch of stuff, and there you have it. You have an application. Then the positive feedback loop is going to be much tighter and much more useful. And I say this as a person that has a very definite attention span. It's very well. I can be hyper focused, but most of the time, if I don't get the results pretty quickly, I usually just bail out and do something else. So if something doesn't grip me, if I don't get like good results immediately, I will either give up and start something else, or I will end up in weird rabbit holes that aren't useful at all. I mean, it's useful if you want to fix a bug, but if you want to write an application, it's probably going to be counterproductive. I don't know if that answered your question. I mean, I went pretty deep into the woods of that, but I think that is the closest thing I can describe as an answer to your question. Maybe. Oh. Good. Sorry, I sometimes I just start rambling and I try to get to a point, and then I realize the point is a little more distant than I thought, and then I have to ramble on again. But yeah, speaking of Python and speaking of developing GNOME applications, we are going to try and write the Python version of the text viewer application that I wrote for in C in the past few streams. The goal of doing that is not to exercise my Python, but because I want to see what are the differences between the set of instructions that I used for the getting started documentation in C, and how many of those apply to the Python example, would apply to a Python code example. Because again, the idea is that we are going to write the documentation in C and then add the port of those examples in other languages. And if we get to a Python example, then we can run a diff and at the very least understand how much of those instructions can be kept as they are how much of those steps can be kept as they are, and how many of those steps have to be modified to be more neutral, and how many of those steps are actually specific to the C language. And if they are specific to the C language, then how do we isolate them into their own thing so that people that are following along in other languages are not confused by them. Like, for instance, we have a couple of cases where we have to modify the class initialization function for a GObject, or in another case we have to modify, I don't remember it's a class init function for adding templates, template children. Template children are defined in another way in Python, JavaScript, or Vala, or Rust, for instance, and our documentation has to adapt for that. So let me see if we can transition to my desktop. And here. We learned so much from the rambling. I hope so. I hope that people can learn from my rambling. Mostly because, yeah, I all you see is unscripted. I'm not reading off an autocue. I'm not doing a YouTube like video of this. I'm literally making stuff up as I go along. So you're finding out as soon as I find out stuff. So we have our text viewer in C here. Then we can start a new project in Builder, and we can call it so we cannot call it text viewer because it's already taken by our C application, so we call it PyText viewer because I lack any sort of imagination when it comes to naming stuff. So example PyText viewer stored in projects. We use Python and we create a GNOME application. So one thing that will change in GNOME 42 and GNOME Builder 42 is that these templates are going to be slightly different. You will have a GNOME application template, which includes GTK4 and libadwaita. Then you will have a GTK application, which only includes GTK4, and then you will have a GTK application legacy template, which is for GTK3. For GNOME, we only consider GTK4 and libadwaita at this point. So if you have GTK3, if you want to start a GTK3 application, why? But yeah, it's going to be a GTK application. So let's create a project here, and we have it. There you go. So it's again very easy way to start with GNOME Builder. Of course, this is still GNOME Builder 41, so it doesn't have the latest bleeding edge stuff from GNOME 42, which means we have to go inside our manifest and request the latest bleeding edge runtime version. So let me see, it's indexing, let's update. We install the latest versions of everything. the build as being configured and it's working. So if you run it, you should see this. As you can see, this is still using GTK 4 and the base template. So you will get the old style for GNOME applications. So we will need to modify our build here by adding, let's see if we have the, yeah, it doesn't check for additional dependencies here, so it's fine. So we go into here. This is a GTK application window. Fine here, that's fine. Inside our main. Yeah. So our main here is not going to be a GTK application, it's going to be an libadwaita application. So if we run it now, yeah, we need to import, of course. And we need to require version 1 of libadwaita. And there you go. Now we have a libadwaita GNOME application. As you can see, the corners are rounded everywhere. The style of the header bar is different. The template in the next version of GNOME Builder will include all of this. So if you run a GNOME application template, if you build a GNOME application template using GNOME Builder 42, you will have exactly this, an libadwaita application and everything else. You will also have a couple of changes in this template. So you will have doc strings everywhere and a bunch of other things that are going to be more interesting for a Python developer, a little bit more Pythonic. Let me see if I can open a project here. I should have select the folder. I don't have GNOME Builder here. I have it in my GNOME here. We don't care about building it. We only care about going over there. Meson templates, resources, and then source. Yeah. So yeah, this is the old GTK 3 legacy. The GTK 4 one, yeah, I haven't pulled. Oh, sorry, I'm on the wrong branch. Oh. Right. Now you can see if libadwaita is enabled, then you get libadwaita imported as well. You get the doc strings for each function. And also something that I added here that will call automatically set accels for action on the application whenever you add a new action for the application. So I added this stuff in the template because this gives us a better, a more Pythonic application template. Let me see what else. Right, so here we also have the window Python here. Right, so it's pretty much the same. It works fairly similarly. Yeah. Our template is here. We can also end up writing something else at another point. That's going to be fine. Even if it's not identical, we don't really care. So let's go on our here. So our getting started tutorial starts with setting text viewer, adding com example text view. We'll probably have to remove this because you can select whatever language you care. This one will have to change. The main entry point of your application depends on the language, and text viewer application, it's not going to be called that way. It's going to be window py and main py here. The other files are pretty much identical. Yeah. Pod files exist here as well. Data includes the gschema. The desktop file, the app data is identical. The resources, it's going to be text viewer gResource XML, so it's going to be identical. The meson build is going to be identical. So this particular section is not going to be changed that much. Yeah, even the file name is going to be different. It's going to be window UI and not text viewer window. This one could be changed in the template. Instead of generating an unnamespaced file, we can namespace it exactly like we do in C. We don't do it in the Python template. I don't know why, but it can be done. It doesn't require any additional change there. We need to fix it inside GNOME Builder. But yeah, so if we go to the next section, we are adding a bunch of stuff. So we are going to end up in the window UI here, and we are going to change it. Same thing we did here. So we're going to add a new property. And then we are going to remove the GTK label here. And instead add the scroll window. Exactly like we did in the C example. And then we add a text view here inside the scroll window. Okay, now we have to change the window code. It's going to be different. We're not going to add a field to the instance structure. So we have to go here. And instead of a label here, we are going to add a text view. So it's going to be this main text view equals GTK template child. We also have a header bar, but we don't use it, so we don't care about it. And this too will be dropped because we don't care about it. Sorry, it doesn't work that way. So in Python, the way templates work is you decorate your class using this decorator, GTK template, and the resource path of your UI file. A resource path is not a file system path, it is a path inside the gResource file here. So com example pytext viewer window UI, it's going to be here. Com example pytext viewer window UI. And just like we did for in C, instead of adding fields in our instance structure, we do it inside the class itself, and we use GTK template child instead of GTK widget class bind template child. This one will, whenever you instantiate pytext viewer window in your code, it will find main text view and will associate the child inside the template to that field. So at this point we can run here, and that's it. Exactly like in C. So our main changes are going to be here. So we might need to have something that is not, like for instance, we'll need to modify the template to ensure that it generates text viewer dash window.py, for instance, instead of window.py. But it's very similar. So maybe, yeah, this entire section here is going to be a tab. So all these steps here are going to be written for C. And then we replace them with a tab that is written for Python. So instead of having code tabs that only replace the code bit, we'll have a tab that replaces the entire section here. So let's see if I can get open a project here. So we let's so let's go inside our tutorial section, beginners, getting started, content view. So the content view is going to be slightly different. For instance, it's going to be this. And then it's going to have a code block. Let's remove a bit of spacing there. So we're going to move all of this into its own tab. It's going to do wonders for our horizontal line length, but I mean, what are you going to do? So, and now we have at our disposal a tab for Python. See if it's aligned correctly. Line on the 5th line. Oh, this one on the 4th. Okay. And basically the exact have something similar. So we start with open the window file. Find the definition of TextViewer window instance and the TextViewer window class. Probably gonna be called like this, but yeah, for the time being we can do this. And then it's going to be replace the label equals GTK template child line with template main text view equals GTK template. Okay, so we do a code block here for Python, and then we go here, copy this stuff, it's going to be 1212. We are going to have to change this. This way. Okay, and we have to emphasize this line. So 1, 2, 3, 4, 5. And we don't need to do anything else. The 4th and 5th steps are not necessary for this. So let's see if this builds. Yeah, we don't care about those. Okay, so let's switch to getting started. Use tutorials. 4th, getting started to Python. Let's push it. Oh, sorry. Yeah, everything up to date, so I need to let's get version origin, delete the branch, and use my shortcut for that. Okay, let's see how it renders. Let's see how it works in a real example, and we can check if this is a viable solution. Because if this is not a viable solution, then we will need basically a Python version of the getting started tutorial, which means having a completely separate build of the tutorial, at which point we'll need to do a lot of copy pasting. including all the XML stuff and blah blah blah. It's going to be a pain in the ass. The other, that would force us to move all the XML examples or bunch of code there into a separate file and then include it from different documents, which is feasible. We already know that that works. That would be probably an easier solution for future maintainability, but still the most efficient way of doing this stuff is literally to try and reuse as much as possible without having to necessarily rewrite everything. Mainly because if you have everything inside the same document, it's easier to update it and to keep it up to date. If you have everything outside of that documentation or worse, replicated, then keeping stuff up to date is going to be really hard. And the main problem of any free and open source software project when it comes to documentation is keeping stuff up to date. Okay, let's go straight into this. Will take forever. No, it doesn't take forever. It takes a little bit. But yeah, it's always keeping stuff up to date. Keeping stuff up to date is the #1 job for any documentation. Any free software projects documentation effort. It's the reason why many projects have terrible documentation, because somebody wrote the documentation once, maybe not at the very beginning. It never happens at the very beginning. It happens once stuff started to settle. So you start writing documentation as an outreach, basically effort, to get more people interested in your project, and more people arrive. You start getting feedback about API or about like convenience and everything else, and you add more API, more convenience, makes stuff more open to newcomers and more you lower the barrier of entry, for instance, and stuff like that, but the documentation stays the same. So newcomers do not learn how to use your API or your project in the most idiomatic way possible. And they have to understand how stuff works, from example, reverse engineer your own API, and that's a pain. So let's go inside the build and let's see how it rendered. It's beginners, getting started. Well, let's go back to the getting started landing page. Yeah, we'll have to change this and remove this, but it's fine. So add your content view. So this one should be exactly the same for the XML bits, and that is correct. Oh, this is terrible. Yeah, the styling is bad. So let me see. Settings. No, it's not in settings. Theme. Appearance here. Colors. No. Advanced. No. What the heck? Yeah, I never remember. Add-ons and themes. Oh, there it is. So let's go with the light theme. If it doesn't crash. Okay. Didn't crash. Great. Yeah, now it's visible in the right way. Ah, God. So, yeah, now it's working correctly. Outside of the theming problem. Right. So now we have the Python version, and that works fine. So, as an approach, this seems to be working. You have a more complicated bit here. Our real test comes from this. Like, for instance, this stuff has a lot of interleaved bits. For instance, we'll need to have a tab that starts from section 6, from step 6, unless we split. So we have the XML stuff here, and we break it off here, and we add another block that deals with this stuff. And adding the open action here is going to be completely different. This one too is going to be complicated because we are going to not have a text sphere window init function, but we'll have an init function somewhere else. And this one, yeah. Yeah, I think this entire section here is going to be a separate tab. Oh, hi, Jeff. And welcome. Yeah, this section here is going to have its own tab in C, even though it's kind of generic. But we will have to basically copy but adapt it to Python. So for this one, we have to break it. And this one we'll have to yeah, select a file. Selecting a file is probably going to be slightly easier because it's all it's already broken down in simpler steps. Right, so let's see. Let's look at that. Let's look at how to make the opening files lesson work. So here, text sphere window UI, that's going to be fine. We're going to rename it. It's not a problem. This one is going to be exactly the same, and here. So adding an open button. Yeah. Okay. So let's add a subsection here. Okay, it's going to be update the UI definition. Here. Find the template in your source. So we're gonna have a different tabs directive here. It's gonna be tab C, and we're gonna start from 1. Code block. And then we are going to modify this to be step 3 with a new code block here. The emphasize line are going to be exactly the same, so we're not going to have to change them at all. Okay, so we have 3 steps here. Okay, so we go back 1 level. There's the Python tab. And then we actually copy this here. We rename the file. So we go back to our content view example. And we copy it here. The syntax highlighting is going to be Python. The emphasize line is going to be different. Because now we want the open button, PK template child. The emphasize line is going to be 1, 2, 3, 4, 5, 6. So this is going to be okay. Let's fix it up so that we have a baseline. Okay, so the open section links to existing stuff that already has our let's see, documentation, tutorials, beginners, getting started. So okay, the action tutorial already has a Python. No, it doesn't have a Python, but it already has different languages there. So adding a Python example is going to be fine. Yeah, it already has some Python example. So it just needs a little bit of tweaking for that. But it's going to be fine. So the link is already fine. Yeah, this entire section here is going to be replaced with a it's going to be a tab for C. And it's going to be a tab for C because the simple action creation is going to be slightly different, and additionally the setting the access for action is going to be slightly different there. So we cannot use a code tab here. Also, yeah, we cannot use a code tab. Also because the instructions here reference specific C-specific stuff. Let me see. Yeah, we probably want to also simplify a little bit, create shorter lines. Horizontally scrolling stuff is kind of bothersome and also generates weird rendering artifacts, as you can see here. So we should probably also fix stuff elsewhere, like this stuff here. I mean, this is not going to be fixable, but this one is. So this is going to be our C code here. Yeah, we're gonna have to. I'm not fond of this because it's going to be slightly different from what the template actually outputs. Because the template is not limited to our indentation, but it should be easy enough to, even if it doesn't match precisely. You can see that it's just adding new lines. It doesn't really matter. Okay. This one is going to be fine. The indentation is going to be completely different. So, sorry, since the indentation has changed and the lines have grown, the number of lines have grown, we need to recount the emphasized lines bit. It's going to be 1, 2, 3, 4, 5, 6. 14, 15, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So 29. 9. So it's going to be 5 lines, so it's going to be 29, 34. So 1, 2. If we add a Python tab now, we'll have to essentially kind of copy this stuff again, but we'll change the examples there. So for instance, modify TextViewer instance initialization. We don't need to specify what it is because in Python, people know what an instance initialization function method is. So in Python, it's going to look like this. Sorry. Yeah, we need to change this to have this open button. We also modify this to add the open button here. Sorry. The header bar. And here we go. So we have the open button now with a new action name. Okay. So we need to add an action to the window. So we have open action. We need to import GIOME. Simple action. Here. So the simple action, in order to do that, we need to go on the documentation for GIO simple action and go into the properties that are inside GAction, and it's going to be the name of the action. So it's going to be name open. Then we have to connect. So it's going to open action, connect, activate. We'll need this. So it's going to be self open file. And then we will need to add it to the window. So let's add the open action is defined elsewhere, so we are going to deal with it later on, but it's going to take the action, the parameter. For now, we pass it. And then inside our application, which is here, we are going to create sorry, not create an action, but we are going to add So one of the things that PyGObject does slightly differently is that it doesn't do class instance initialization there. I mean, we could add all this stuff inside the instance in it as well. So creating an action there. Let's see if we can move it here. We will also need to modify the template for this. But for instance, if we do this, set maxels for action, it's going to be win open, and then it's going to be control O. Hi Rednov, welcome. See if it works. Yeah. Yeah, it worked perfectly fine. So we'll have to modify the template for that. So we are going to modify the template to create the action inside the instance in it, just like we do in C, and not when we activate the window. In the template update that I already pushed to GNOME Builder, we have the create action also has an additional here if shortcuts. It's going to do self set backcells for action name and then shortcuts. Because then we can add additional actions with shortcuts there. So for the time being, we're going to add it there because we expect the template to have it in the near future. But yeah, we'll need to modify GNOME Builder, the GNOME Builder template, to move the create action call from the do activate virtual function to the instance initialization. But for now, that's fine. So here, so this is the C tab, this is the Python tab. The Python tab is going to be different because we are going to have it look like this. And it will, yeah, it's not going to look like this. It's going to look like this. This will have to be changed. This is going to be there and this. So we emphasize line 1, 2, 3, 4, 5, 6, 7, 8, 9. So we emphasize line 9. And for this one instead, we are going to go inside the window and do this. For the time being, we are going to have to copy everything. It's going to be here. Yeah, we'll have to modify the templates for this stuff as well, because we are not going to have this. This one should be really called text viewer application to match the C code. Oh yeah, we are relaxing with Python. It's probably easier to follow. So we have to rename this stuff. here. We'll have more stuff to emphasize. So we're going to emphasize lines 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 15 and 16. And this instead, we're gonna emphasize line 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Okay, still fine. Okay, so let's build it and see if we forgot something. No, that's fine. Let's see how it renders. This one don't care. This one we don't care. Yeah, we'll see how it renders. If it renders okay, then we can continue again. But yeah, so as you can see, the overall approach of separating the entire sections, not just the code examples, can probably scale upwards. There aren't many, so the opening files and saving files sections are the most complicated because of the asynchronous API, which is going to be fun when we get there. But on the other hand, like for instance, the save, outside of the name of the functions here, which we could keep, it's not strictly speaking terrible there, but we can keep it, or at least keep some of them. They are completely isolated functions here. But yeah, for instance, in this, the add a key shortcut for the save as action is going to be replaced entirely with another set of instructions for Python, because it doesn't map at all. Instead adding, job succeeded. Okay. The version of in Python is going to be a lot simpler because we only have a couple of places where we have to modify stuff for actions and everything else. So adding content view, loading content from a file. So this again is exactly the same, and in Python is a lot simpler, as you can see. So it's still a couple of instructions, but it's missing the entirety of section number 3, of step number 3. And adding the open action is again pretty similar. we add an action here, and we add the accelerators here. And now we have to go into the opening file. So maybe we need to change the name. Like in this case, it's called TextViewer window open. Oh, we need to fix this. TextViewer window open file. Yeah, maybe we need to fix a bunch of stuff there as well. Hi, Abentagil. And hi, Georges. Next language, Vala. I used to know Vala. I don't know enough to write documentation in Vala. I apologize. I'm really sorry, but I would struggle a lot worse than Python. Like maybe we need to rename it open file here, so that open file here also matches the same thing. The parameter we don't care, so we can make it here look like this. Yeah. So if we rename this open file, okay. The function that would be called when the action, so we can make it generic there. This part will stay outside of the code, the tab. So the parts that go outside of the tabs have to be as neutral as possible, as generic and language neutral as possible. So tabs. This one is going to be the C tab. So we're gonna indent it here. And then now that we are here, we are going to have an interesting gotcha for Python developers, which is going to be fun. I mean, we already exposed this gotcha here in the components tutorials. This is going to be here. Oh, no, this doesn't need to be indented as much. And this has to be renamed open response. Okay. I should probably... Okay. Let me have a look. Preferences. Editor. No. Okay. I usually don't do this because it's a lot of extraneous like stuff. But I need to count spaces now. Okay, so let's copy this entire section here. But we have a Python. So inside the open file method, so this is going to be Python. We're going to eliminate this stuff. This is the window here. So open file. So self native equals GTK file user native. And here we are going to go inside the tutorial for this. And we're gonna literally copy this. Because it's a lot easier to deal with this stuff like this. Transient for self, because we are a window. Okay. So self native connect response self on open response self native present. Sure, sorry, not present. And then we'll have the on open response self dialog. Pass it and try it. Yep. So this worked, which means we can implement this here. If response equals here, then we can do self open file and get file, and then we delete the native here to replicate this. We need to implement open file. Right. So open file is going to be defined later on. So we can just pass here. Okay, so we have the Python version tested. Let's go again, open. Oh, sorry. Takes 2 position arguments, but what the heck? What's happening here? Let's see. File chooser native. GDK file chooser. Okay. What the heck? It's probably something very stupid because... Yeah. Come on. Is this a word-known text viewer implemented in Python? Yes, it is. Self-native. This is weird. Was working like 5 seconds ago. Oh, because I'm an idiot. I'm redefining open file. Yeah. Okay. Self. Yeah, I need to also add. Yeah, this is not really necessary. I'm just adding because I was debugging, but that's fine. But yeah, I'll have to find a new name because I cannot use open file again. I mean, I could do this, but I mean, it's gonna be fine, but yeah. Yeah, for the time being, we'll keep it that way. Okay. So inside the open file method, we are going to add the native dialog. So we're going to do this. One, two, three, four. The open response method. Another Python code block here. And we delete this bit. Not this one. Okay. 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 Yeah, that makes sense. We should probably link the tutorial on the file selection dialog. So it's going to be something like the same thing we do here. Where is it? Yeah, here. So we are going to link the file selection dialog. Like this. And it's gonna be tutorials, components, file dialog. Sorry, no, beginners. Yeah. So that people will be able to go back there for more information. So we don't have to be exhaustive here. A file selection dialog, the user. Let's see if everything works. Okay. And now we need to rename it because it's gonna be, otherwise it's gonna be a pain in the ass. So we're gonna rename it. Open file is the open file dialog. So maybe we need to rename it as open file dialog, like this. Instead of being a generic open file. And this one is on open response, that's fine. On open response instead calls open file. Okay. So we have it, we call it open file dialog, on open response, and this one is called open file. I apologize. I have somebody has rung the bell. Just 1 second. I'll be back shortly. And we're back. Sorry about that. People ringing the doorbell. So yeah, this is going to be open file dialog. So we need to rename it here as well. Open file dialog. Okay, and we'll have to rename it in the C file as well. File dialog. Okay, here. And now we have the open file here. And at this point we can have, yeah, this one is kind of generic. Open file and open file complete are kind of names that we could reuse in other languages. So we can have this and use code tab. And then have a code Python. And for that we need to implement it now. Okay, this one is gonna be open file dialog, and this is gonna be open file. So we have a GIO file here. So we're going to do file load contents async. We don't need any cancelable, so it's going to be none. And then it's going to be self open file complete. And nothing else. And then we are going to do complete self file result, and it's going to be file load contents finish result, and it will return to us the contents and the length of the contents. Let's see if it works. Yeah, again, open file dialog. Okay, so too many values to unpack. Oh, it means it returns a contents array, so it's going to be just like this. Yep, it is. Returns true and contents. Okay, so it's an array with two elements there. So why did it... This one should work though. This is weird. But yeah, let's see if it works this way. Yeah, it doesn't unpack correctly. This is weird. Well, let's see what happens. So now we have this. This one is gonna make an error, so it's gonna be something like try. Oh, it's gonna be an exception for for GIO. So let's see what happens here. Okay, so here we'll have to do a bunch of stuff. There, the UTF-8 validation. It's gonna be fun. We can skip it for now. And then we have to get the buffer. Okay, so we are going to do something like buffer equals self main text view get buffer, and then we'll have to do set text. Okay. Can stringify and see what happens there. So we run it. Right. So now we get this. Oh, it's because it's a Boolean and an object, of course. So this is another case of the Python bindings being a little bit weird. So this one should be, in theory, handled by the overrides. Yeah, we don't get it there. File. Yeah, there are no overrides for GIO file. But in practice, you would need yeah. So yeah, in theory, you would need to do something like this. Like the unpacking. Something like unpacking. So if len contents equals 1, equals it's going to be something like this. Why is it doing this? Do I need to unpack it? No, because it's not G variant, so shouldn't be unpacking anything. If it's a G variant, I need to unpack it, but it's not a G variant here. Yep. It's a result of tuple. Okay. Why is a result tuple? Yeah. This is a it's a PyG object thing. In theory, this one should be overridden. Yeah, content. Yeah, no. No, okay. Yeah, in this case, it's gonna be... It's because this will contain... So, in theory, in Python, in PyG object, I could still do this. And contents will contain what is it? False and none. And in theory, the the Python GObject bindings will create a wrapper around it. Should have a wrapper around it that will turn the contents result tuple into an actual result, an actual value, or raise an exception. But we don't have it. It's kind of like an option, well, kind of result data type. It is kind of... Yeah, it must be a string, not bytes. As you can see, now it's working because, yeah, it handles like that. So it's gonna be the code UTF-8. And there you go. Yeah, it's always it's so weird. Decode or encode. It's decode to UTF-8 and encode to UTF-8. I always have to like think about it. It's like righty-tighty, lefty-loosey kind of thing when using a screwdriver. So the actual implementation would be like print out an error if the decoding fails. But right now we don't care. Okay. Okay, so yeah. So at this point, we will need a code block. So we have a code block for the reading the contents of a file in Python. So open file here. And this is going to be another tabs. And this is going to be a code tab. And now we have a Python code tab. Okay. We can 1, 2, 3, 4. We can print out an error. And we can print it out like this, and it's gonna be fine. But yeah, the result tuple is going to be, let's see if I can get it inside the so it's going to be here, PGI result tuple. So yeah, it basically pickles the entire thing. Where is it? Okay. Yeah, it basically adds a bunch of stuff inside the same result. It's a C type. It's implemented in C. It's not even implemented in Python. So let's see if there's an example of the override. Okay. It's in the cache. I want to see how to unpack this stuff. Yeah, because in theory, it should take the Boolean value that gets returned and then also take the actual, all the out arguments. So if a function has a bunch of out arguments, it will pack them all into the result tuple. And if there is an error, if there is an G error at the end, it should also contain that. Let's see if there is some way to unpack this stuff. Yeah. It's the strip boolean resolved. There you go. There you go. Yeah, basically what it does is you take the return. If the first value of the return object, which is a result tuple, is true, then return everything else. Otherwise, raise an exception type. And the exception type is passed by this function. So every time you do strip boolean result here, you can also return a fail value. But basically all this it does is PyGObject has a bunch of overrides written in Python, in pure Python. Unlike the old PyGDK bindings where everything was written in C using CPython. The overall idea is that you have access to the underlying API using introspection, which is fine. Then you add overrides to make the C API look a lot more like a Python API. So a little bit better. So there's all this magic stuff called, in this case, just strip boolean result. It takes a result, which is what PyGObject will generate for every function that is fallible, for instance. So it has a G error at the end, or has multiple return values, so multiple out arguments in C. And it will take that, and if it has a Boolean return value and a G error at the end, it will take everything and then it will raise the exception at the end. But all of this is done in pure Python. It's not done in C. Sadly, GIO doesn't have these overrides, especially not all of GIO, but Gfile doesn't have Gfile bindings don't have these kind of overrides, which is annoying because you have to do it yourself. So the load contents finish will return a Boolean value signifying whether or not the function succeeded or failed, and then it will have the contents data inside it. So I could, in theory, do a deconstructed object assignment, but that's going to be a pain in the ass. So yeah, this stuff should be fixed in the PyG object bindings, but it's not, so we'll have to deal with that ourselves. So in this case, if it's, yeah, if the first element of the contents object, which is the result of this operation, is false, then we emit an error here. And in case of error, we would probably get the G error as the second one. So this would look like this. It would be, yeah, probably a stringified G error. If we wanted to have an actual exception, it would be that we can catch. It would be different. We would need to raise that exception ourselves, which is annoying. And I'm not going to do that. Also because I'm not going to raise an exception I'm catching at the very same time. Okay. So all of this can be replaced. Yeah. So this is going to be a tabs. This is going to be a tab for C. Because we don't need all of this stuff in Python at all. I mean, I'll also have to add comments here and there because otherwise it's going to be a pain. And okay, it's gonna be fine here. Then we're going to add 1 through 3. No, it's gonna be it's gonna be a pain in the ass. Okay. Why are you making me work so much? So this is going to be here, 7. Having to re-indent everything is pain. Pain peckle. Okay. Almost done. Almost done. Almost done. Okay. Okay. Oh, Jesus. So we need to copy all of this. Let's see. Okay. No, it's misaligned. Yep. Now it's correct. Okay, so we don't need to emphasize these lines. We need to emphasize fewer lines because we have fewer code. So we're going to copy this. And now we can do this. Okay, 1, 2, 3, 4. Good. And then we do, we don't have to, the decoding, the UTF-8 decoding in Python is a lot more, it's a lot nicer than everything else, so it will do a lot of this work for us. So we instead of using else, well, no, we can return here. We can do text equals contents 1 decode UTF-8. And we emphasize this line only. So it's gonna be 1, 2, 3, 4, 5, 6, 7. And then we have the other block that is exactly the same, but it's going to be yes. And then we do the exact same thing. Buffer equals self main text view get buffer set text, and then we can emphasize lines 3, 4, 5, 6, 7, 8, and 9. And the last bit is going to be changing the position of the cursor. So start, it's gonna be buffer get start. Start here, and then buffer place cursor at the start. Yep. It's actually going to be a little bit more than that then. It's going to be 8, 9, 10, 11. Let's verify that we haven't introduced some terrible output. And let's see what happens when we push to our remote. Yeah, basically it's going to be something like this. And then buffer place cursor at the start. Yep. Oh yeah, this one works fine. And then changing this will require getting the display name and then updating the title. So we're gonna break this into bits and do stuff like file query info it's gonna be a standard display name, GIO file query info flags none, then no cancelable. Okay. And then if info 0, display name is going to be info get attribute string otherwise we use the base name file get base name, and then we do window set title display name. Oh, it's not subscriptable. Oh yeah, it returned. It's a. Of course, in this case, instead, since consistency is key, it returns an info directly. So I'll have to check if there is an override. If there is an override, it means that there's a lot of work to do in the Python Python bindings. Yeah, it's not window, of course. It is self main window. Sorry, self. We are inside the window. And there you go. This has worked as well. Okay, so we have our additional contents 0. We are going to do text equals contents 1 encode UTF-8 else text equals empty string, and then we do this text here. Yeah, so we can change the implementation here. Yeah, we also need to... Yeah, no, we can do this. Let's copy it. Well, we're not going to copy this, but it's fine. So this. We need to separate the sections so that we can easily go back. So it's not going to be 8 anymore. And this is not going to be 7 anymore. It's going to be 8. 8, 9, it's going to be 10 to 13. And updating the title of the window, it's going to be tabs here. This is going to be a code tab. Since it's a single change. It's also a lot of indentation. Yeah, re-indenting everything is going to be a pain. Especially in the larger code samples. Position the cursor. And set the title. Okay. Finally, the Python code tab. We are gonna copy here. This. An emphasize line later on, but now we can copy this. This one is going to get copied. So before we do this, we need to go back here and then query the info in order to get our display name. And then after setting a cursor, we set the title. So we have to highlight lines 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 13, 14, 15, 16, 17, 18, 19, 20, 21. Let's build it and see if there are warnings or anything else. Seems to be okay. No, it's fine. And now push a fix up, and we push to the merge request. Yeah. And if we have been good, then we'll see different tabs there. Yeah, it's gonna be a little bit annoying reindenting the entire world. I would love not to have to deal with this. But yeah, so the end result should be that we have been porting the C code to the Python language so we can have examples in Python. And if we have examples in Python, then hopefully somebody will come around and open a merge request for JavaScript and Vala, which we already had, for the other the UI components and other tutorials, which is good. So kudos to everyone that contributed. Your work is very much appreciated. But if this should make it easier to have more documentation in different languages. And finally quell the rumors that we don't care about other languages. Okay, so loading content from a file. The XML is fine. Okay, here we have the C version. I'll have to fix this. So the open button here will have to be rejigged. Not going to be 9. It's going to be a lot after that. 10, 11, 12, 13, 14, and 15. So. And this one will also need to be a lot more than that. But in Python, it's a single line and it's great. This one too will have to be expanded. So it's going to be 6 to 7, 8, 9, 10, 11, 12, 13. But in Python is this one, perfect. And accelerator is here. See, the accelerator is here and it's correct. So in C we have the file chooser native, and same as in Python. And on open response, that's fine. By reading the contents of the file is a single line, and again it's fine. On find complete, here, here. Load the contents. If there are no contents, print an error. I can see, yeah, we print an error there. And then we show the contents of the area here. This is C, and ensure the validation, and retrieve the data there. In Python, it's going to be validate UTF-8, and then modify the contents of the text buffer. We'll need more comments there. Here we need to get the display name and set the window title. Same here, we get the display name and set the title. This could have been self.props.title, that's the same. And yeah, this screenshot shows the C, like, adding a tab for showing the output in the Python language. It's going to be, yeah. Could probably find a different target, like opening up instead of the main C file. Again, I could open the copying file for the general public license. It's gonna be the same in every project, so maybe it's a better idea. I had to take a new screenshot, but yeah, that's fine. But yeah. Oh, it's been 3 hours. I'm not going to continue. But we kind of proved the approach at this point. Having tabs and code tabs for our example code in different languages. And if we can deal with Python and C in the same file, we can deal with JavaScript and Vala in the same file as well. It's going to be a little bit longer and it's going to require more contributions, but it's going to be doable. So I'm quite pleased with that. Okie dokes. Let's switch back to my big Ed. Okie dokes. So, yeah, we started porting the text viewer example application from our getting started tutorial to, well, from C to Python. We discovered a couple of issues in the Python bindings, and we also discovered a couple of issues in the template for Python GNOME applications inside GNOME Builder. Hopefully those will be fixed by the time GNOME 42 rolls around, but I'll have to check with the Python GObject maintainer for some of the changes there. Georges is printing out weird messages. Oh, the Stream Deck. You're having fun with the new Stream Deck. Good. I hope you're having fun, because you do realize that once you make it work, I'll be able to buy it as well. And then we'll rely on your applications and your code. I do promise I'll contribute if I can. Oh, that would be nice, having icon uploading. Yeah, a Stream Deck is just a fancy custom keyboard that you can upload images to, and basically just will perform an action every time you press a button on that. It's used by streamers, but also it's used by gamers and other people that require very custom actions, and they have to perform them using, like, they have to perform them constantly. I've seen people using it using a Stream Deck with CAD applications. You can also use it with, like, I don't know, Photoshop or whatever. Because not every graphic tablet has a lot of programmable actions. But yeah, I've read of people doing that. So, and Georges is going to work on making it look really nice when using GNOME. So I'm gonna hold you to that. Using WebSockets, Jesus. Oh my god. IPC mechanisms, what are they? But yeah, I kind of guessed that, because they yeah. Yeah, I'm not gonna provide sneak peeks here, but I'm actually writing a small tool that deals with how's it called, timing, quick timing for, like, things like speedrunning and stuff, because there is one that everyone uses on Windows, which is open source and written in C#, but it doesn't work on Linux, which is very bad. So I was toying with a small application that would do exactly that. So at this point, we are literally speedrunning the Linux desktop into the streaming between OBS and everything else. The sad part is that a lot of plugins for OBS are actually written in, like, for Windows, so having those for Linux would be a lot better, outside of the stuff that uses literal web pages. Like, most of the overlay I'm currently using is actually a web page. So it's hilarious how this stuff works. Yeah, I mean, it's the CF, it's an entire web browser inside of your broadcasting application. What? And it's used to do like overlays and stuff. It's... what? Is it a surprise that you really need a beefy hardware to make it? to make streaming happen? It's an entire OS in the application. Yeah, I can bet. Oh my goodness. Anyway, I guess it's time. I guess it's time for a little outro for YouTube. So, if you enjoyed watching me writing code in various languages to document the GNOME software development platform for our application development, then consider subscribing to my YouTube channel. Leaving a comment and pressing the like button is also very much appreciated, so that the almighty algorithm and the all-knowing eye of Google will shine its light on my little channel. Otherwise, if you want to look at what I'm doing live, you can follow me on Twitch, twitch.tv/ibasi, and you will get a notification whenever I stream, which is usually on Monday, Wednesday, and Friday. Of course, I say this, but on Wednesday I will probably not stream because I am otherwise engaged in the evening, so it will be hard for me to stream for more than an hour. In any case, you will see a notification whenever I stream. But if you stayed up until now, after 3 hours and 10 minutes, congrats. Thank you very much. And we shall see each other the next time. Wednesday, probably, if not Friday. Have a great rest of your day, and see each other soon. Bye.